7.6, the last section of chapter 7 that we're going to work on, is solving equations with rational expressions. So now we've done all of this adding and subtracting and multiplying and dividing with same denominators and different denominators and canceling. And so now what we're going to do is we're going to put all of that together and we're going to solve equations. We're going to find out, what is this x equal to anyway? All right, that's what solving an equation is finding out what does our variable equal. So once again, here's some steps. Here we go. So solving equations is actually easier in one way than either adding, subtracting, multiplying, or dividing, because what we're going to do is, step one, we are going to have to find the least common denominator of all the denominators in the entire equation. All right, so step one is find the LCD of all the denominators. So you might have 3 or 4 or even 5 denominators, and you've got to find the LCD of all of those. So that's the hardest part. Because after that, step 2, you're going to multiply both sides of the equation by the LCD to get rid of the denominators. If you multiply every term in that entire equation by the same thing, you have not changed the value of your equation at all, but it will make it easier to solve because you will totally eliminate all of the denominators. And I'll show you how that's done. And then step 3 is to solve. You'll have a simple equation that you just add, subtract, multiply, and divide to get the x by itself like we've done before. So step 1, find the LCD of all the denominators. In our first problem, we simply have constants. We have a 5, a 2, and a 4. So if you'll remember, to find the LCD, we're going to list our prime factors. 5 is just 5. The prime factors of 2 is just 2. The prime factors of 4 is 2 times 2. So your least common denominator is going to have to be the 5 times 2 2's. So 5 times 2 is 10, times another 2 is 20. So 20 is the LCD. All right, now here's the deal. You don't have to get all of these fractions alike when you're solving. All right, what we're trying to do is we're trying to eliminate everything down to just have the x left. So what we're going to do is this. We're going to do step 2. We're going to multiply both sides of the equation by 20 in this case to get rid of the denominators, because watch this. When I multiply everything, I've got to multiply every part. Every part has to be multiplied in order for this to stay equal. So every part gets multiplied by 20. And I actually write that on my paper. Every part is times 20. Because when you do that, look, 5 times 4 is 20. 2 times 10 is 20. And 4 times 5 is 20. So I'm able to reduce those. Remember, we're multiplying fractions so we can reduce ahead of time. We can cancel things out. And when we do this, my denominators now are all 1. So now, when we multiply through and we get our new equation, we multiply the 4 times x and we get 4x. So 4x equals 10 times x is 10x minus 1 times 5 is just 5. And this is an easy equation to solve. So what we'll do is we'll subtract the 10x from both sides. And so we've got what? Negative 6x equals negative 5. Divide by negative 6. So x is 5/6 because a negative divided by a negative is a positive. So 5/6 is your answer and you're done. All right, let's do another one. Let's do one because you know I'm going to make it a little more difficult. Let's do one that has a binomial involved. In this case, I only have 2 fractions involved, and I'm going to throw a little, you can either multiply everything by the common denominator and get, your common denominator is going to be x minus 3 times 5, but that's the same as doing this. Watch this. If you have just one fraction equals another fraction, do you remember that that's the same as a proportion, and in your proportions, the cross products are equal? All right, so I can just multiply 5 times x and get 5x, and I can say that that is equal to 2 times x minus 3. And now I don't have fractions to deal with. Okay, pretty cool, huh? Now that only works if it's a fraction equal to a fraction without, like this, if there's a minus involved, that's not going to work. Okay, so if it's just a fraction equals a fraction, just cross multiply and don't deal with all of the extra shenanigans. Okay, so now it's just a simple equation to solve. Make sure you take your 2 all the way through. So 5x equals 2x minus 2 times 3 is 6. So subtract your 2x from both sides. 3x equals negative 6. Divide by 3. So x equals negative 2. All right. Now be careful. Be sure. Now that we have fractions, remember, you cannot have 0 in the denominator because that is undefined. You cannot divide by 0. So you always need to check your x back into any of your denominators and make sure they don't make your denominator equal to 0. So go back and check negative 2. Negative 2 minus 3 is a negative 5, so that is not equal to 0, so we're good to go. All right, does that make sense? So check to make sure that for extraneous solutions is what that's called. Check to see that your denominator, make sure that your denominator doesn't ever equal 0 if you plug back in your answer. All right, in this one, your denominators are x. If you don't see a denominator, then your denominator is 1, remember. So x and 1 and 1 and 1. Oh, so what I've got here is just times x. So everything, now remember though, I can't, let's just get rid of the denominator. Everything has to be multiplied by x. All parts. So now I end up with, these x's will cancel, so I have 3 minus 5x equals x times x is x squared minus 3 times x. Do you see where I got that? I multiplied everything by x, but this one the x is canceled. All right, so now I'm going to add 5x to both sides. So 3 equals x squared plus 2x. Subtract 3 from both sides. So now what I'm ending up with is, oh dear, I'm going to come over here. Can you follow me so you don't get confused? So 3 minus 3 is 0. And then we end up with the x squared plus 2x minus 3. And now remember, the whole point of this is we're trying to solve. We're trying to find out what does my x equal. So remember, to solve a trinomial, I'm going to factor it out. So x times x is x squared. The signs are different. So one positive and one negative. And 3 times 1 is 3. And I want my bigger number to be positive. So 3 and 1. So check it to be sure. 3 minus 1 is indeed 2x, so we're good to go there. Now remember, we're not done yet. So if 0 equals this times this, that means either x plus 3 equals 0 or x minus 1 equals 0. All right. Now subtract 3 from both sides, so x equals negative 3, or add 1 to both sides on this one, and x equals 1. So there's my two solutions. Now we have to go back in and put them in for x. Negative 3 can be in the denominator, and 1 can be in the denominator. Neither of those make the denominator equal to 0, so we're good to go. So my answers are negative 3 and 1. Let's do 2 more. You can do it. Hang in there. All right, in this case, let's see. Your denominators are all just x plus 2, right? Easy. So that means that we're going to multiply everything times x plus 2. Remember, this whole thing times x plus 2. Oop, not 12. This whole thing times x plus 2. And this whole thing times x plus 2. Don't forget, everything in that entire equation has to be multiplied by the same thing in order for your equation to stay the same. So your x plus 2's cancel here. So you've got x squared minus 3 times x plus 2. So you're going to have to take the 3x times the 2, so minus 3x. Now be careful, this is a negative 3 times a 2, so minus 6. And that's going to equal, oop, my x plus 2's cancel. So x plus 6. And then minus 4x. And then the negative 4 times the 2 is minus 8. All right, so now I'm going to do several steps at the same time, okay? So this x and negative 4x, we're going to put these together and get a negative 3x, right? So that equals negative 3x. So I'm going to add 3x to both sides. And this 6 minus 8 is the same as -2, so I'm going to add 2 to both sides. Okay, did you see? Did that confuse you too much to do that? I'm running out of space is why I did that way. So I combined these. This x minus 4x was -3x. And so a -3x, in order to get rid of it on that side, I'm going to add 3x to both sides. And this 6 minus 8 is a -2. And so to get rid of that, I'm going to add 2 to both sides. And so now I have x squared minus 4 equals 0. So when I factor this out, x plus 2, x minus 2, remember this is a perfect square minus a perfect square. So now x plus 2 equals 0. Have I gone down far enough? Can you see me still? So set your x plus 2 and your x minus 2 equal to 0. Let's do it over here. So you're going to subtract 2 on both sides for this one. X equals -2 and add 2 on both sides. So x equals 2. So here's my two solutions. And then we go back in. Oh, looky here though. -2 plus 2 is 0. Can I have a 0 in my denominator? No, I cannot. So this one is extraneous, which means it answers my problem, but it is not a solution to the problem. So then we check the other one. 2 plus 2 is 4, and that's okay to have in the denominator. So x equals 2 is my solution, and -2 is an extraneous solution. All right? Okay, I'd like to do one more with you, so hang in there. The last problem that we have, 5 over x minus 3 equals x over x minus 2 plus x over craziness. Well, step 1 is to find the LCD. In order to find the LCD, you need to know what the factors are, right? So factor it. Here we go. Always factoring. If you're having trouble with factoring, you need to go back and brush up on that. X times x is x squared. Positive, so the signs are the same. I want to add so that my signs are different, so they're both negative. Or sorry, add so my signs are negative, so they're both negative. And I know that 2 times 3 is 6. So 2 times 3 is 6, and 3 plus 2 is -5. And lo and behold, x minus 3 and x minus 2 multiplied together give us what we had already. So there's our common denominator, is both of these together. So I'm going to multiply every part by that whole denominator. So x minus 2, x minus 3, x minus 2, x minus 3, x minus 2, x minus 3. So all of it. Remember, multiply every part of what's in your equation. So now this x plus 3, the whole thing, the whole binomial will cancel. And this whole x minus 2 will cancel. And now this will all cancel with both the x minus 2 and x minus 3, because remember, this is both of these together. So now I have my 5 that I need to distribute through the x minus 2. So 5x minus 10 equals, and the x needs to be distributed through the x minus 3, so x squared minus 3x plus, and all that's left here is just x, because the denominator canceled out and I don't have anything to multiply by. So combine like terms, x squared minus 2x equals 5x minus 10 on this side. Subtract your 5x. Now the reason I'm moving it over to this side is to keep my x squared term positive. It's just easier to work with that way. Don't lose your negative sign here. Negative 10 equals x squared minus 7x. Add 10 to both sides. So 0, which is what I'm looking for, equals x squared minus 7x plus 10. So now when you're solving for x, we're going to factor again. Lots and lots of factoring. X times x is x squared. Signs are the same. This says that the signs are both negative. So I want 5 times 2. And now negative 2 plus negative 5 is -7. So remember, if this times this equals 0, either x minus 5 equals 0 or x minus 2 equals 0, one or the other. Solve each one, add 5 to both sides here, so x equals 5, or add 2 to both sides here, x equals 2. Now, you can't be done quite yet. Remember, you've got to check. So 5 minus 3 is 2. That's fine. 5 minus 2 is 3. That's fine. And we already checked both of those factors. So the 5 is one of our solutions. 2 minus 3 is negative 1. That's fine. 2 minus 2 is 0. So 2 cannot work because it gives me a denominator of 0, and you cannot divide by 0. So 2 is extraneous. And 5 is my only solution. All right? So don't forget, find the least common denominator of all the denominators. That's the hardest part. Once you find that, multiply through and get rid of all the denominators, and then you've got an easy problem to solve. Just solve for x and you're good to go. All right? See you later.